In the winter of 1941, deep inside a Moscow military communications room, a telegraph operator stared at a message that didn't sound like the others. For months, he had been translating frantic reports: cities burning, divisions wiped out, generals begging for reinforcements. But this one carried a different kind of urgency. It was an order, not for rifles, not for shells, but for tanks. And not just any tanks. The Soviets wanted 3,000 British Valentines, a model most British commanders had already written off as outdated. It would become the single largest tank order of the entire war. At that moment, Stalin's armored forces were being destroyed faster than the factories could build replacements. Operation Barbarossa had torn into the Soviet Union like a wildfire, consuming everything in its path. By December 1941, more than 20,000 Soviet tanks had been lost, some to German guns, but most to their own weaknesses. Engines froze, fuel ran dry, tracks snapped in the snow. The mighty KV-1s and endless rows of T-26s looked impressive in parades, but on the battlefield, many simply stopped moving. And a tank that can't move is nothing more than a steel coffin. The Red Army was learning a cruel truth. Numbers meant nothing if the machines couldn't survive the winter. Meanwhile, aid was beginning to trickle in through the new Lend-Lease program. America promised Shermans. Britain offered Matildas and Valentines. But the Soviets didn't just take whatever was available, they chose carefully. Their observers in London had spent the previous year watching British units train through bitter cold. They interviewed crews coming back from North Africa, and they noticed something that even the British Army itself had missed. While newer, heavier tanks sat broken in workshops, the little Valentine kept rolling. It wasn't glamorous, it wasn't fast, but it worked. So when Moscow's order went out, 3,000 Valentines, delivery to start immediately, Arctic route priority. There was no explanation attached. The British assumed it was convenience. In truth, the Soviets admired something much deeper. The Valentine wasn't powerful because of its engine or armor. It was powerful because it was simple. Where Soviet tanks demanded entire factories to fix a single broken track, 3 mechanics could strip and service a Valentine in a matter of hours using basic tools. To the Soviet engineers, this wasn't backward, it was brilliance. In a war where survival depended on what could keep moving, the Valentine's simplicity wasn't a flaw, it was genius. The brilliance of the Valentine tank wasn't in its gun or its armor. It was in its simplicity. Its transmission came straight from the kind of trucks you could see on British roads. That meant no rare metals, no special tools, and no waiting weeks for replacement parts. In war, everything breaks eventually. The question is, can you fix it? The Valentine's designers had built a tank that answered yes. For the Soviets, that mattered more than any fancy feature. Their own tanks had power and size, but when one small part failed, the whole machine became useless. They needed something that would start in the bitter cold, something soldiers could repair in the mud and snow without a factory behind them. So when they asked for 3,000 Valentines before the Russian winter locked the land in ice, it wasn't just panic, it was strategy. They knew this obsolete British tank could do something their advanced designs often couldn't: keep running. The Valentine story actually began long before it reached Soviet hands. In 1938, engineers at Vickers Armstrongs had submitted a new tank proposal to the War Office on February 14th of all days. That date gave it its unlikely name, the Valentine. But there was nothing romantic about how it was received. British officials glanced at the design, a modest 2-pounder gun, lighter armor, nothing flashy, and quietly filed it away. Britain already had the mighty Matilda II, a heavily armored fortress on tracks. Why build another slow, ordinary-looking tank? What they missed was the philosophy behind the design. Vickers engineers had spent the 1930s watching Europe rearm for war. They'd seen what happened when countries built complex machines that couldn't be produced or repaired fast enough. So they focused on practicality, tried and tested parts, simple construction, and components that could be made by ordinary British truck factories. It was a tank designed for reality, not for parades. Then in 1939, war arrived and suddenly, the boring Valentine didn't seem so boring anymore. France had fallen, and Britain was desperate for tanks, any tanks. The Matilda II was strong but painfully slow to build. Each one needed special cast armor plates, and there simply weren't enough foundries to meet demand. That's when the Valentine quietly became Britain's workhorse. The tank that could be built fast, fixed easily, and sent wherever it was needed. And soon, it would find itself on the frozen plains of Russia, where its reliability would turn it from a forgotten design into one of the most trusted machines of the entire war. By the summer of 1940, Britain was running out of time and out of tanks. France was collapsing. Invasion seemed days away, and the War Office suddenly rediscovered an old design that had been sitting in a drawer for nearly 2 years, the Valentine. It wasn't revived because generals fell in love with its features. They didn't. It was revived because Britain desperately needed something it could build fast, and that's exactly what made the Valentine special. Unlike the complex Matilda, which needed heavy industrial casting, the Valentine was straightforward. Its hull was riveted together using simple steel plates. Its suspension came straight from commercial truck parts. Its turret was tiny and uncomfortable, but quick to produce. Factories in Birmingham, Newcastle, and even as far away as Montreal began turning them out like clockwork, using assembly lines originally built for buses and delivery lorries. By mid-1941, the Valentine had quietly become the most rapidly produced tank in the entire British arsenal. It wasn't glamorous, but it worked. Among British crews, feelings about the Valentine were mixed. Inside the turret, 2 men squeezed together in a space smaller than a telephone booth. The commander had to juggle everything: the radio, the gunner, the driver, and the battle itself, all while ducking shells. The gun, a 2-pounder, was fine against early German armor but hopeless against the newer panzers of 1942. Crews joked that the Valentine was built for small men with no personal space. Yet, despite the grumbling, there was one thing every crew admitted: the Valentine never let them down. It started, it ran, it got them home. In a war filled with complex machines that looked better on paper than in the mud, that reliability meant everything. The generals who once dismissed it had made a classic mistake. They'd confused sophistication with effectiveness. Vickers had built a tank that didn't chase perfection. It chased survivability, and soon, that would matter more than anyone imagined. Because on the other side of Europe, the Soviet Union was bleeding tanks faster than it could build them. And when the Valentine shipments finally began, its modest design would prove worth more than any grand specification. In October 1941, the first Valentine tanks bound for the Eastern Front were loaded onto merchant ships in Liverpool and Glasgow. Each one was greased, sealed, and chained to the deck, braced for 2 weeks of hell in the freezing Atlantic. The Arctic convoys had just begun their deadly rhythm: PQ-1, PQ-2, PQ-3. Each voyage a gamble against U-boats, aircraft, and blinding storms. By the time the Valentine tanks joined the line, the Germans had noticed the pattern. The northern route to Murmansk was now a battlefield in itself, a narrow, icy lifeline where British steel and Soviet hope traveled together toward a war that would decide the fate of Europe. The Arctic route to Russia was the shortest way, but it was also the most dangerous sea corridor on Earth. Convoys left from Iceland or Scotland, then swung north, hugging the frozen coast of Norway before cutting through seas where daylight vanished for 20 hours a day. Out there, the cold was a living thing, a predator that waited patiently. German U-boats prowled the black water from their bases hidden in Norwegian fjords. Overhead, Luftwaffe bombers hunted through the clouds, and somewhere in the fog, German surface raiders waited to strike. The men on those merchant ships knew the odds. If a torpedo hit, they had minutes, sometimes less, before the ice-cold water shut their bodies down. And still they sailed. They sailed because Stalin's armies were holding by inches, and every tank that reached Soviet soil meant another day of survival. 2 ports became lifelines: Murmansk and Arkhangelsk. Murmansk, warmed by the Gulf Stream, never froze even in the dead of winter, a small miracle that kept it open despite being constantly bombed from the air. Arkhangelsk froze solid each winter, but during the brief summer months, it could unload mountains of cargo. On the docks, Soviet workers had turned unloading into an art. Cranes swung Valentine tanks from the cargo holds. Steam hoses melted the protective grease from their hulls, and within hours, trains were already carrying them eastward, still wearing their British factory paint. At first, the numbers were small. 87 tanks arrived in January 1942, 112 in February. By March, more than 200 Valentines a month were reaching Soviet crews, even as German ships and submarines fought to stop them. Convoy PQ-13 limped through the Barents Sea that March, losing 5 ships in running battles with U-boats and destroyers, but the Valentines made it to Murmansk. 4 months later, PQ-17 would not be so lucky. Acting on a false alarm about the battleship Tirpitz, the British admiral in charge ordered the convoy to scatter. It was a disaster. 24 merchant ships went down, many carrying Valentine tanks that never reached the front, lying now in silence on the Arctic seabed. Despite those losses, the effort never stopped. Soviet representatives stationed in Britain attended factory meetings at Vickers, watching every stage of production. They inspected welds, checked variants, tracked which ports loaded the most tanks, and sent detailed reports back to Moscow. Their conclusion was always the same. The British were over-delivering against impossible odds. The cost, however, was immense. The men who sailed those convoys faced death rates as high as frontline soldiers. The Royal Navy escorts, destroyers, corvettes, trawlers, fought endless duels against submarines and aircraft in freezing storms. Most of their names were never recorded in Soviet reports, but without them, those 3,000 Valentines would never have reached the men who needed them most. In the Arctic port of Murmansk, Soviet dockworkers unloaded ships under the scream of German bombers. They worked through blizzards and explosions, drenched in freezing spray, refusing to stop even when the siren sounded. Every Valentine tank that made it onto the rail cars was more than a piece of British engineering. It was a monument to courage. Behind each one stood the sailors who had crossed oceans of ice and death to deliver it. By the end of 1942, more than 2,000 Valentines had reached Soviet soil, and those little British machines were about to face trials that no engineer in Birmingham could have imagined. The winter of 1941-42 turned the Eastern Front into a laboratory of suffering. Nature became the examiner, and she was merciless. Temperatures plunged to 35 degrees C, then 40 degrees C, in some places even lower. Steel snapped. Rubber shattered like glass. Grease turned to glue. German tank crews, veterans of Poland and France, suddenly discovered their proud panzers were fair-weather machines. Every morning began with the same grim ritual. Crawl beneath the tank, light a small fire under the oil pan, and pray you didn't crack the engine block. If the flames burned too hot, the metal split. Too cold, and the oil stayed frozen. It could take 3 hours just to bring a tank to life. And when the Maybach engines finally coughed awake, they ran rough and sluggish. Gearboxes screamed because the thickened oil wouldn't flow. Hydraulic gun systems froze solid, turning fast-firing cannons into single-shot weapons. Even the simplest things failed. Hatch seals turned to stone, letting icy wind pour in. Tracks froze to the ground overnight, so every dawn began with crews hacking them loose with hammers. Batteries gave up completely. The 12-volt systems barely had enough power to spin the starters. In that frozen wasteland, precision engineering meant nothing, and that's when the first Soviet crews rolled out their British Valentines. They looked at them with doubt. The turret was cramped, the guns small, the armor thin. A tank from a warmer climate, some joked. But in the brutal cold, the Valentine began to prove its worth. While German panzers groaned and stalled, these modest little tanks started without fires, moved without complaint, and kept rolling long after others froze in place. It wasn't luck. It was the design philosophy that had once made British generals shrug, the same simplicity that Soviet engineers had admired months before. The Valentine didn't just survive the Russian winter. It thrived in it. When the first British Valentines arrived at Soviet bases, the reaction was underwhelming. The tanks looked small, almost fragile beside the hulking T-34s and KV-1s, and when the crews learned they ran on petrol instead of diesel, they shook their heads. If the German engines couldn't handle the cold, how could these British ones possibly survive? But when the tests began, the little Valentine surprised everyone. At 30 degrees, while other tanks groaned and died in the cold, the Valentine's engines turned over again and again, steady, dependable, alive. Incredibly, they were the most reliable cold-weather starters in the entire Soviet inventory. Even homegrown designs struggled where these British machines did not. The secret wasn't advanced technology. It was practical design. The AEC petrol engine wasn't built for Russia. It had been designed for service from the burning deserts of North Africa to the damp chill of English winters. That meant it could handle both heat and cold without major modification. Its tolerances were loose, enough to keep working even when the oil thickened to sludge, and Soviet mechanics quickly learned tricks that made the Valentine nearly unstoppable. Each night, they drained the oil, warmed it beside a fire, and poured it back in before dawn. A 30-minute routine that got the tank running while German crews were still crouched under their panzers, lighting fires and praying their engines wouldn't crack. The Valentine's gearbox was just as forgiving, a simple 4-speed system built with extra spacing between components, so even when lubricants stiffened, it still shifted smoothly enough to move. None of this had been intentional genius. British engineers hadn't designed for the Russian step. They had simply avoided complexity, and by doing so, they'd built something that bent under pressure instead of breaking. In January 1942, during the Soviet counteroffensive near Moscow, field reports began to tell an extraordinary story. While T-34s and KV-1s suffered engine seizures and transmission failures, the imported Valentines just kept running. One Guards regiment fighting near Klin recorded 7 of 9 Valentines still operational after a week of 35°C blizzards. Half their T-34s, by contrast, had frozen into useless hulks. Even the Valentine's modest 2-pounder gun held up better in the cold. Its recoil system relied on steel springs rather than hydraulic fluids, which meant it didn't seize when the temperature plunged. So when the German tanks finally rumbled to life hours later, their crews found themselves facing British machines that had been battle-ready since dawn. It wasn't glamour or innovation that made the Valentine a success. It was restraint. Vickers' designers had chosen reliability over power, simplicity over sophistication, and in the brutal winter of 1942, those boring decisions became a masterpiece of survival. Engineering. Even the lubrication system, and something most designers barely thought about, reflected that quiet genius. Instead of relying entirely on pumps and valves, the Valentine used splash lubrication, where the motion of the engine itself distributed the oil, crude perhaps. But it meant there was less to freeze, less to clog, and far fewer parts to fail. In a war that worshipped complexity, the Valentine's secret weapon was humility. It didn't try to do everything, it just refused to stop working. If the Valentine's engine had a secret, it wasn't hidden behind any mystery. It was right there, splashing oil around like a farm tractor. Instead of fancy pumps and precision valves, the crankshaft itself had small scoops that flung oil upward as it spun, coating every moving part, the pistons, the valves, the bearings. It was old school, almost primitive, the same system found in tractors and delivery lorries. More modern tanks used complex pressure systems that forced oil through narrow channels under high pressure. On paper, that was the smarter design. Smoother lubrication, better cooling, higher efficiency. But there was a catch. Pressure systems were fragile. A single blocked oil line, a seized pump, or a tiny leak could destroy an engine in minutes. And in the middle of a Russian winter, everything that could freeze did freeze. The Valentine splash system, on the other hand, was beautifully stubborn. As long as there was oil in the sump and the crankshaft turned, the engine was alive. It wasn't elegant, but it was practically indestructible. That same philosophy carried through the entire design. The engine sat in the back of the tank under heavy steel plates, but plates that could be unbolted with ordinary tools. No cranes, no factory workshops, just a few crewmen with spanners and determination. 3 soldiers could pull the entire power unit out in under 4 hours. More often, they didn't need to. Most fixes could be done right there in the field. Fuel pump jammed? 10 minutes. Carburetor icing? 15. For Soviet mechanics used to the T-34, a tank that often needed a crane just to reach its engine, this kind of accessibility felt like a small miracle. Many of them grew genuinely fond of the Valentine. It was a machine that wanted to be fixed. That friendliness came from another quiet piece of wisdom inside Vickers' design office. They hadn't tried to reinvent the wheel. Literally, The Valentine's AEC engine was a modified version of the same unit used in London buses. Its gearbox shared parts with commercial lorries. The road wheels and suspension springs were drawn straight from existing supply chains. This wasn't cutting-edge technology. It was industrial common sense. If a spring snapped or a track came loose, a replacement wasn't some rare military part. It was something British factories were already making by the thousands. Even Soviet factories, once they realized how standardized the components were, began producing Valentine spares locally, not because they were advanced, but because they were simple enough to copy. And then there was the cooling system, another example of sensible restraint. Most tanks at the time used high-pressure cooling to raise the boiling point of water, squeezing more efficiency out of smaller radiators. But that came at a price. The systems ran hotter, the seals were delicate, and when they failed, the results were catastrophic. The Valentine didn't chase efficiency. It chased reliability. It ran a straightforward low-pressure cooling loop that traded a little performance for a massive increase in durability. It could take damage, leak a little coolant, and still keep running. In a war obsessed with power, the Valentine proved something quietly revolutionary. That sometimes, the smartest machine in the field is the one that never tries to be clever. On paper, the Valentine's cooling system looked outdated, even primitive. Most tanks of the era used high-pressure cooling to boost efficiency. It worked fine until something went wrong. A single bullet hole or a cracked pipe, and the scalding coolant would blast across the engine bay, leaving the tank dead within minutes. The Valentine did things differently. Its system ran at a lower pressure with a larger coolant reserve. It wasn't fancy, but it could take a hit and keep going. Lose some fluid? No problem. The crew could just pour in more water. Soviet tankers even carried spare bottles for that very reason. That same practical thinking carried over to the electrics, where German tanks relied on compact 12-volt systems, delicate, fussy, and prone to freezing. The Valentine used a rugged 24-volt setup with thick wiring and oversized switches. Nothing was miniaturized. Nothing was fragile. If corrosion built up, a soldier could literally scrub the contacts clean with a wire brush. The batteries sat in easy reach, ready for maintenance. And even in the bitter cold, they had enough power to turn the engine over when others failed. For Soviet crews, that kind of dependability meant everything. They weren't sentimental about machines. They cared only about whether a tank would move when ordered and fight when needed. And the reports coming back from the front lines in 1942 and 43 told a clear story. Crews trusted the Valentine. Some even demanded to stay with their British-built tanks instead of transferring to newer American models. One officer, Lieutenant Dmitry Loza of the 3rd Guards Tank Army, put it plainly in a report written in February 1943. The Sherman is a fine tank in summer or autumn. It is fast, powerful, and comfortable, but in winter below -30, I choose the Valentine every time. The Sherman needs long preparation. The Valentine simply starts. Loza's men kept 3 Valentines operational through that brutal January. Their readiness rate was 85%. The 4 Shermans in his unit managed just 40. The American tanks had their own struggles with the cold. Their engines, 5 car motors joined together into one complex system, were marvels of engineering, but not of simplicity. Each bank had to fire in perfect harmony, and in sub-zero temperatures. That harmony often collapsed. Engines ran rough, pistons misfired, and the very sophistication that made the Sherman powerful became its greatest weakness. The Valentine, by contrast, was a lesson in humility, a machine that didn't try to impress anyone. It simply worked. And in a war fought through snow, mud, and fire, that was the difference between a tank that looked good on paper and one that brought its crew home alive. Later versions of the American Sherman came fitted with powerful radial engines that handled cold weather better. But there was a catch. They drank fuel like thirsty giants, and for Soviet supply lines already stretched thin, that was a serious problem. Both Sherman engine types also sat deep in compartments that were anything but mechanic-friendly. In the field, Soviet crews were used to fixing broken machines with little more than wrenches, hammers, and determination. But the Sherman demanded workshops and proper tools, luxuries rarely found near the front. The Valentine, by contrast, was as straightforward as a tractor. Its gun, the modest 2-pounder, couldn't match the Sherman's 75mm cannon for range or firepower. Soviet crews knew this well. Yet in battle after battle, they discovered that a gun which fired was worth more than one that didn't. Senior Sergeant Nikolai Yakovlevich Zheleznikov told the story best. In January 1943, near Stalingrad, his unit fought in temperatures dropping below -40. "Our gun fired the moment I pulled the trigger," he wrote. "The German tank opposite us never fired at all. Later, we learned its recoil system had frozen solid. My crew survived because our simple British gun worked." What British crews once mocked as cramped, that tiny turret where 2 men worked shoulder to shoulder, became a blessing in the Russian winter. The confined space trapped body heat, keeping the crew alive and the instruments workable. The smaller turret also meant a smaller target, especially when camouflaged under snow. And since snowstorms and fog often reduced visibility to just a few hundred meters, the Valentine's short-range gun was suddenly no handicap at all. Soviet tankers adapted quickly. They learned to fight on the Valentine's terms. They moved at night or under blizzards when German armor was least likely to start. Time and again, British-built tanks rolled into position before dawn, engines warm, guns ready, while German crews were still crouched under their vehicles, coaxing frozen machines back to life. One veteran, Sergeant Ivan Pavlovich Goncharov, whose Valentine served through the Battle of Kursk, summed it up years later in his memoir. "The British gave us a tank that refused to quit. It wasn't fast, it wasn't fierce, but every morning it started." To Soviet engineers, the Valentine was no sacred foreign marvel. It was a reliable foundation, a machine they could adapt, improve, and trust. In a war where even steel could freeze to death, that kind of loyalty from a tank was rare. The Valentine didn't go everywhere on the Eastern Front. It went where the cold bit hardest. The Soviet High Command sent most of them north, to the Guards tank units and the brigades defending Moscow, the regions where winter was less a season and more a weapon. The 1st Guards Tank Brigade got the first shipment in December 1941. Within months, they had enough Valentines to form an entire battalion. Another batch rolled to the 50th Tank Brigade just as the winter counteroffensive began. By the middle of 1943, more than 40 Soviet brigades and regiments were fighting with British Valentines, some using them exclusively, others mixing them with Soviet-built tanks like the T-34. The partnership went even further than most people realize. In the Ural city of Sverdlovsk at factory number 37, Soviet engineers actually began building Valentines themselves under license. Between late 1943 and early 1944, about 130 locally produced Valentines rolled out of those workshops. They were small in number but uniquely Russian. Wider tracks, Soviet-made radios, better heating for the crew. Small improvements that made the design feel at home in the brutal East. By then, the Red Army had something rare, a front-row seat to compare Allied technology side by side. Technology side by side. 3 main Western tanks reached the Soviet Union in large numbers. The British Matilda de Seine, the British Valentine, and the American Sherman. Soviet crews didn't judge them on theory or design. They judged them on survival. The Matilda arrived first. At the time, it was considered almost indestructible. 78 millimeters of armor across the front, thicker than anything the Germans could reliably penetrate in 1941. Soviet soldiers called it the Queen of the Battlefield. In the desperate fighting around Moscow, that armor saved lives, but the Queen had her flaws. She was slow, painfully slow, barely 15 kilometers an hour over rough ground, and she ran on 2 separate diesel engines that had to work in perfect harmony. When one went out of sync, the whole tank stopped dead. In Russian winter, that happened a lot. Still, those first Matildas bought the Soviets something invaluable: time. They stood their ground when almost everything else was falling apart. But it was the Valentine that truly won Soviet hearts, not because it was powerful, but because it never stopped moving. For all its armor, the Matilda turned out to be a mechanic's nightmare. Soviet engineers cursed its engine bay, cramped, complicated, and packed with twin diesel motors that demanded delicate synchronization. It needed British tools, British parts, and British patience, none of which were easily found on the Eastern Front. By mid-1942, the tone of Soviet field reports had shifted from admiration to frustration. The Matilda's armor was still respected, But its engines and gearboxes weren't. Too many broke down before ever reaching battle. Then came the Americans, and with them, the Sherman. By 1943, thousands of M4 Shermans were crossing into Soviet ports. Over 4,000 would arrive before war's end. It was a completely different machine, faster, roomier, and better armed. Its 75mm gun could punch through German armor, and its suspension made it one of the smoothest rides on any front. Soviet crews were amazed by its electric systems, especially the stabilizer that let gunners fire accurately while on the move, something almost unheard of in Soviet tanks of the time, but the Sherman had its demons too. Its tall silhouette was easy to spot across the open steppes. Its gasoline engine turned deadly when hit. A single penetrating shot could turn the tank into what soldiers grimly called a cigarette lighter. And when winter came, the Shermans suffered badly. Below -30, their engines froze and their vaunted mobility evaporated. That's when the humble Valentine proved its worth. It wasn't the fastest. It wasn't the strongest. But it was steady, and in war, steady wins. The Valentine struck the perfect balance for Soviet needs. Solid armor without excessive weight, a gun powerful enough for most threats, and an engine that simply refused to quit. It was easy to maintain, simple to repair, and could be kept running with tools and materials available in the field. Even Soviet procurement officers, famously unsentimental men who trusted numbers, not feelings, took notice. They tracked everything: mechanical downtime, fuel efficiency, crew casualties, and mission completion rates. Across the board, the Valentine performed best in one crucial category: reliability. During the freezing campaigns of 1942 and 1943, brigades equipped with Valentines maintained operational readiness between 70 and 80%. Units with Shermans or Matildas struggled to stay above 50. That's why the orders kept coming. Britain built about 8,600 Valentines in total, and more than 43% of them went east, to the Soviet Union. No other Allied tank was delivered in such massive proportion. In the end, the Valentine wasn't glamorous. It wasn't a hero's tank, but it was there, always starting, always moving, always fighting. And for the Red Army, that made it priceless. The first Soviet order for 3,000 Valentines went out in 1941, and against all odds, the requests kept coming. Through 1942 and well into 1943, even as newer and stronger tanks appeared on the front, the Soviets still asked for more Valentines. Not because it was the best tank on paper, it wasn't, but because it always worked. For the Red Army, reliability meant survival. A tank that started every morning, moved when commanded, and fired when needed was worth more than any technical marvel that froze, jammed, or broke under stress. The Soviets knew exactly what they were getting. The Valentine was never a mystery. Thin armor, a modest gun, and a painfully cramped interior. The reports said it all. But those same reports also told another story. This little British machine was one of the few foreign tanks that stayed operational through the worst the Eastern Front could deliver. You can see it most clearly at Stalingrad, in the brutal winter of 42-43, as temperatures plunged to -35. Several Soviet tank brigades encircling the German Sixth Army were driving Valentines. While German panzers sat motionless in the snow, their engines frozen solid, the Valentines kept starting. They were not destroying tigers or smashing through fortifications. They were doing something far more important. They kept moving. Their small 2-pounder guns couldn't pierce heavy armor, but they could tear apart the trucks, half-tracks, and supply convoys that kept the German lines alive. That reliability, not firepower, helped tighten the noose around Stalingrad. A few months later, at Kursk, the Valentine story entered its final chapter. By summer 1943, Soviet factories were turning out thousands of T-34s, and the Valentine was clearly outdated, but it still fought. Why? Because the Red Army's entire support system already knew how to keep it running. The spare parts were in the warehouses. The mechanics knew every bolt and seal. The crews didn't need retraining. And in a war that punished inefficiency, those details mattered more than raw power. When the German offensive opened on July 5, 1943, Valentine units were assigned to guard the flanks, protect infantry, and hold ground the enemy thought unimportant. They weren't the stars of Kursk, No one wrote songs about them, but they did their job quietly and well. Their task was to endure. And in that, the Valentine never failed. By 1944, the Valentine was long past its prime. Newer Soviet tanks outgunned it, outpaced it, and made it look like a relic from another war. Yet on the frozen fields of the Eastern Front, a handful of Valentines still rolled forward. Some units kept them because switching to the T-34 meant retraining entire crews and reorganizing supply chains, luxuries no commander could afford in the middle of non-stop offensives. Others found new uses for them. Old Valentines became command vehicles packed with radios, tow tanks dragging the wounded machines of war back to safety, or scouts working the quieter edges of the battlefield. A few even fought on into 1945, stubborn reminders of a desperate time, still moving when so many supposedly superior machines had fallen silent. But the real story of the Valentine wasn't about firepower or armor. Its legacy was something deeper. It proved that reliability itself can be a weapon, that a tank which always starts in the cold is more valuable than one that looks impressive on paper. It showed that toughness, simplicity, and trustworthiness often decide battles long before the first shot is fired. Soviet engineers never forgot that lesson. In the years after the war, when they designed the T-54 and the long line of tanks that followed, they carried a bit of the Valentine's philosophy with them. Make it strong, make it simple, make it work in any weather. Between 1941 and 1944, the Soviets received 3,082 Valentines. Many were destroyed in combat, others simply worn out. Some vanished into the confusion of endless retreats and advances. But during those critical winters, when the fate of the Eastern Front hung by a thread, it was these quiet, dependable British machines that refused to stop. They didn't win fame or headlines or parades, but they helped win the war by doing the one thing that mattered most. They kept going. They kept going.